Okay guys, on to question 7. So to start off, you can see there's what we call an ion table here. This table is just there as information to help you. You don't have to fill anything in there or do anything. It's just telling us that all of the things here are 1 plus ions. So sodium is 1 plus. It's obviously an atom that's tried to give away 1 electron, and so it's ended up with 1 more proton than it has electrons, and so it has an overall a 1 plus charge. You know, things like magnesium, everything in this column, but things like magnesium have given away 2 electrons and become a 2 plus ion. Alright, and same thing for everything else here. We've got the 2 minus ions, the 1 minus ions. Alright, so the table underneath it is what we actually have to fill in. And it asks you to put the formula for sodium chloride as our first one. So all we got to do is find in our table here sodium, there we go, and chlorine. So these are going to combine to make sodium chloride. And if I have a look at it, because the sodium is 1 plus and the chlorine is 1 minus, they're going to fit straight together. We can just put NaCl like this. Now there's no pluses or minus now because they've cancelled each other out or balanced each other out. We've got a 1 plus charge on the sodium, a 1 minus on the chlorine, so overall they fit just nicely together like that. Oop, I didn't mean to move that one. Yeah, so there we go. If we go on to something like potassium oxide, it's just a little bit more complicated. We've got to find potassium in our table, so there we go, is potassium, and oxygen, which forms the oxide ion, this one here, or the O2 minus, right at the very top there. So they're going to combine, and this time we aren't going to be able to put them just straight together because we've only got 1 positive charge and we've got the 2 minus. So if we just do this one, just give me a sec. We've got 1 potassium is plus, and we've got oxygen is 2 minus. Alright, should put the little charges up the top, like that. Okay, and if we add another potassium now, ooh, made that a little bit little, there we go, another potassium plus ion, there we go. Hopefully now you can see we've got the charges to balance. We've got 2 potassiums and 1 oxygen. So we've got 2 1 pluses and a 2 minus. We've got 2 positive charges overall and 2 negative charges. And so that's basically telling us, like, potassium, each potassium atom was giving away 1 electron, the oxygen is picking up 2 electrons, so we need 2 potassiums for every oxygen. Alright, so we're really just balancing out these charges. We need 2 positives for every negative. So our final answer here is going to be K2, K2, sorry, K2 there we go, K2O, 2 potassiums and 1 oxygen. So I'm going to make that even bigger. Alright, cool. So this next one here, aluminium sulphide. Come back and grab I'll do another different color again this time. So we've got aluminium is here and sulfur is here. So we're combining them. Now it's aluminium sulphide, so it's just aluminium and sulfur, it's these two. If it had said sulfate, then it would have been this one here, the SO4. It would have also included oxygen. But because it's sulphide, I know it's just this aluminium here with this sulfur one here. So how are we going to balance these ones? Well, this time we've got Al, and it's actually a 3 plus. Where did I go? A 3 plus ion. and sulfide, just like the oxygen here, that's a 2 minus. Alright, so we've got an aluminium, a 3 plus, and a sulfur 2 minus. So if we look at these, do we have too many positive charge or too much negative charge? We've got too many positive, so we add another one essentially to this side. We add another sulfur over here. Right, and now we've got 4 minuses, so 2 on this one and 2 on this one, which means now we've got too many minuses, so we're going to add another aluminium to the other side. Alright, so if you have a look at this, sorry, just got to format it a little bit. Now I've got 6 pluses and I've got 4 minuses, so we're now too heavy with the pluses, alright? But if we add another sulfur, like this, then hopefully you can see now we've got our 6 pluses and our 6 minuses, 2 on each of these. So our final formula here is going to be Al2, alright, and then we're going to have S3. Alright, so the final formula will look like this: 2 aluminiums and 3 sulfurs. No pluses or minuses on there anymore because they've all balanced out. We've got 6 plus total charge on this and 6 minus total charge on the sulfurs. So each aluminium is actually trying to give away 3 electrons. Each sulfur is only picking up 2, and that's why we need that combination. For every 2 aluminiums, we need 3 sulfurs, so that the 6 electrons they're giving away, the 3 sulfurs will pick those up. So Al2 S3 is our final answer there. Alright, the next one, ammonium oxide. Now that's a really mean one, and ammonium is one of the ones that can be a little bit trickier to remember. You'd always have the formula though, so you don't have to remember the formula. You just need to be able to recognize that this one in the corner, NH4+, that this one is ammonium. So we've got ammonium as one of our big ugly ions, carbonate, sulfate, nitrate, hydrogen carbonate, and hydroxide are the nasty ones that you need to know. So we've got here ammonium, and so my let's put that one in already. So ammonium, NH4 plus. Now the thing that really confuses students sometimes is the 4 in there. It's not a 4 plus. It is still in the 1 plus column. So this whole thing, NH4 altogether, is just 1 plus. So I'm going to change the plus to a different color just to kind of highlight that. The 4 has got nothing to do with it. We're not interested in that part at all. It's a 1 plus ion. Now what that means is that when it combines with, we've got oxygen. It's combining with oxygen, which is a 2 minus ion. Alright, and so again, I'll just highlight the charge different color. Just change that. So you can see here we've got 1 plus and we've got our 2 minus. So which one do we need more of? Well, we need more of the plus to balance out the negative charge. So if I have 2 of these NH4s, now I've got 2 pluses and a 2 minus. The charges are balanced. So again, NH4 is a little group of atoms here that all together, they're trying to lose 1 electron. They become a 1 plus ion. And oxygen is trying to gain 2 electrons to become a 2 minus ion. So when they combine, we need 2 of the ammoniums and only 1 of the oxygens to balance the 2 positive charges here with the 2 negative charges on the oxygen. So how do we write the formula for this? Because ultimately, if we just type in here, if I just put in NH4, 4, right, now I've got 2 of those. I can't just put a 2 on the end because it's going to look like NH42. So with any of these big ugly ones, now they're called polyatomic ions as their official name, but any of these ugly ions, the ammonium, the carbonate, the sulfate, the nitrate, and the hydrogen carbonate, the ones that already have numbers in them, or the hydroxide, so in this case it's just any of the ones that have more than one type of atom in them. So they're not basically an element, they have more than one type of atom in them. If you need to use more than one of them, you just chuck the whole thing in brackets. So in this case we chuck the NH4 in brackets. Okay, we chuck the NH4 in brackets, and then after that we can put a little 2. So that's telling me here I've got 2 ammoniums, 2 NH4s. And then after that we've got 1 oxygen, so I just put the O on the end. Alright guys, the very last example. Alright, running out of different colours here, so just back to the beginning one. We've got magnesium, there's a 2+ over here. Alright, and nitrate is our NO3 over this side over here. Alright, so Mg and NO3. I'll just scroll up a little bit. Alright, that's kind of mixed up things a little bit. Let me just highlight that again. So we've got Mg and NO3 over here, magnesium and the nitrate ion. So when those have combined together, we're going to get magnesium is a 2+, so Mg 2+, combining with NO3. Oh, that's a little bit little. Combining with NO3, and if we have a look at those there, we can see that NO3 is a 1-. So we've got NO3. So again, don't get confused by the little 3 there. It's NO3. The whole thing is just a 1-. Alright, so Mg is 2+, NO3 is 1-. So you can see from the column it's in the same column as the chlorine 1-. Alright, so which one do we need more of? We need another NO3. Alright, the whole thing. Let's put that a little bit higher. Alright, and so now if I've got 1 magnesium 2+ and 2 of the NO3 1-, you can see hopefully here I've got 2+, and I've got the 2 single minuses here. Alright, so we're balancing out those charges. 2+, and altogether we've got 2-. So our final formula, we've got 1 magnesium, so we just put an Mg. We never have to put in we don't have to put in the number 1 if there's just one of them there. So Mg, and then NO3, it's one of my big polyatomic, my ugly ions. So I've got to whack that into brackets, NO3. Alright, there we go, NO3 in brackets. And on the outside of that, we're going to put a little 2. Tells me I've got 2 nitrates. So we've got 1 magnesium and 2 of the NO3s. So, in a test, guys, things like sodium chloride, if you can do a couple things like that, you're probably looking at achieved. If you can do some of the more complex ones like the potassium oxide here and the aluminium sulphide, you're probably looking at getting towards merit. And if you can do the ones with brackets like these last 2, that's going to be sort of an excellence level. Alright, guys, but ultimately there's a few examples for you and how to go through them. You always just identify from the name which ions on this table we're using, and then balance out the number of them so that the charges overall balance. So 2+ with our 2- ones. Alright, that's basically it. I hope you found that helpful. Alright, and we'll go on to the next question.